Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our learning on PVTP software for condensate modeling, compositional retrograde condensate modeling. And in previous two videos, we have checked the result for CCE and for CVD. Now we will check the quality of the match for the current fluid in the separator experiment or separator calculation. Okay, to do that, here we already have the separator object in our calculation window. So we can just double click and then press calculate and then go to results table, select the stage results. All right, and maybe we can compare it with the sample. I double click the sample, enter lab data, and then separator. Okay, so we have two stages here. The data for the oil density for the second stage is at 771, whereas for the model, we get 786 kilogram per meter cube. Okay, so in terms of the oil density from the equation of state, it compares very well with the reported value from the lab data. Okay, and the difference is somewhat around 2.2%. Whereas for the calculated GOR, we get 6,028. And it is very close with the data, which is 5,919. Okay, it's around 2% difference. Okay, so in terms of separator train calculation, we have relatively good matches for the GOR as well as for the liquid density. All right, in summary, the fluid model, the current equation of state model, currently provide an adequate description of some of the fluid's properties. In this case, the liquid density and the GOR from the separator experiment, and also maybe for the Z factor from the CCE. While the liquid dropouts are not very well matched up to now. And now we can take a moment to consider these outcomes, these results, and we can also consider the steps to develop a possible regression strategy. An example of the development of a possible strategy you can read in PVTP manual, but it's somewhat like first, you can create a list of the current objective, and you can rank the objective in order of declining importance. So the objective is like to match the phase envelope, to match the saturation pressure, to improve the matching for the GOR, for the liquid density, and also for the liquid dropout, and also the position of the critical point in your phase envelope. Okay, so these are the objectives that you want to achieve in your characterization. So the saturation pressure, liquid dropout, liquid density, GOR, and the shape of your phase envelope. Or in other words, the position of the critical point. Okay, so you can create a list of current objective and you rank them in order of declining importance. And then you can consider what pseudo properties will affect each of these objective and by how much. Like how does objective X change if you change Y? Like for example, for high importance, we consider matching the position of critical point of high importance. Then the most important parameters you can adjust to get a better matching for the position of critical point are critical temperature, critical pressure, and binary interaction coefficient. And if you want to improve the matching for the liquid dropout, you can adjust the critical temperature, critical pressure, binary interaction coefficient, and volume shift. If you want to improve the quality for the saturation pressure, then the most important parameters or properties to be adjusted are TC, PC, and BIC, binary interaction coefficient, something like that. And then the next thing, you can consider how changing the selected properties for regression will affect the other objective. And then you can consider which parameters would be more difficult to readjust at a later stage. And thus you decide on a suitable anchor point. If you want to get the best practice, I think you need to read the PVTP manual. All right. So I think I will consider the strategy background. Okay. And in the next video, we will continue with the primary regression. Okay. Until then, thank you so much for watching and see you